Right, so we're going to finish section 4.3 off with a few more examples of our predictions and interpretations and kind of put this all together. So this is going to be example 3 for this section. We're going to look at home runs and RBIs. So this scatter plot shows the association between the number of home runs and RBIs for the best home run hitters in the major leagues in the 2008 season. What do we know from looking at this scatter plot? Right, so we're going back to section 4.1 here, right? This and 4.2 a little bit. This scatter plot shows a relatively strong positive linear trend, right? So there's not a lot of scatter. We could get more specific using our correlation coefficient from 4.2 if we wanted to, but it's a relatively strong or pretty strong positive linear trend. Since it is positive, since it is increasing, the data suggests that the players who hit a large number of home runs, right, so as X increases, as a player hits more home runs, then they also tend to hit a large number of RBIs. Right? So as the X increases, the Y increases as well. So that's our what we get from our scatter plot. Right, can we predict the number of RBIs for a player with 25 home runs? Yes, we can, because on the previous page we were given an equation. Our equation was right up at the top of our graph. Our predicted RBIs was equal to 30.46 plus 2.16 times the amount of home runs. So we're going to, for this prediction, plug in a value for our home runs. So our predicted RBIs are going to be 30.416 plus 2.16, which is our slope. Again, that's our y-intercept, this is our slope, times 25. That's the value from our problem. We plug that in, we get 84.416 RBIs. Again, when you're answering these types of questions, if you're asked to round to a specific decimal place or maybe the nearest whole number, make sure you're doing that as well. All right, we can go kind of one step further. We can write a nice sentence interpretation of this. A player with 25 home runs tends to have approximately 84 RBIs. So we took our prediction and we wrote a nice sentence. Again, remember that we like to use words like tends to, right, when we're doing stuff like this, because it's not a certainty, right? It's just a prediction. All right, interpret the slope and the y-intercept. So our slope, again, is that 2.16 that's attached to our x variable. Right? The slope tells us that for every additional home run a player hits, so for every time that x increases by 1, right? So anytime, and our x is our home run, so anytime a player hits another home run, they also tend to hit 2.16 RBIs. So they also tend to increase by 2.16 RBIs, which is our y. So again, our slope is talking about a relationship for every 1x, what does y do? For every 1x, y increases by 2.16. Our y-intercept tells us that a player who hits no home runs, tends to hit 30.46 RBIs. So that was the other number from our problem. Right? This is a case, unlike the last example, where our y-intercept could potentially be useful information. Right? A player who hits no home runs tends to hit 30.46 RBIs. Granted, if we're taking the largest home run hitters, that may not necessarily be the case. So we just kind of want to take a look at our y-intercept at the end, decide if it is even something that's possible, and whether or not it is going to be something that is useful for us in our interpretation. Okay, so in this example, again, we kind of summarized a lot of what we've done in chapter 4 so far. We talked about what we can get from our scatter plot. We made a prediction using our linear regression line, and then we interpreted our slope and our y-intercept.